So let's put to work what we've learned so far. Pause the slide and tell me what the formulas for the compounds made from the following ions are. The copper 2 ion with a nitride ion and the iron 3 ion with a bromide ion. Okay, so let's look at what we know. Copper 2, that's copper, and its charge is indicated by this Roman numeral, which is 2. And because it's a metal, it's positive. Nitride is capital N, and because of its position in the periodic table, 3 columns away from the noble gases, it's -3. Now I'm going to follow the same procedure that I used for my other ionic compounds and switch the numbers associated with the charge. So I bring my 2 down here and my 3 next to the copper, and so I end up with copper 3 N2. Now over here I'm going to double check to make sure my charges cancel out. If I have 3 coppers, that's +2, +2, +2. That's a total of +6. If I have 2 nitrides, then I have a total of -6, and these equal 0. They cancel out. Okay, now let's look at our other compound here. Iron is +3, bromide's -1. I'm going to do my switch. I bring down my 1 here and my 3 here, and I get FeBr3. And I'm going to do my check to make sure my charges cancel out. I have 1 iron, so that's a total of +3, and I have 3 bromides, each with -1, which is a total of -3. So my charges cancels out, and these are the correct numbers. Now notice, my 3 does not mean I have 3 irons. It means that's the charge of my iron, and from that we determine what the formula is based on what the charge of the anion is. Now pause this slide and see if you can name the following compounds. So we know this is an ionic compound because it begins with K, which is a metal. Here is K right here, potassium, an alkali metal. It also always has a +1 charge because it's an alkali metal. And then chloride is not a polyatomic ion, and so we're going to retain its root and end it in "ide." So the name of this is potassium chloride. We know that this is an ionic compound because it begins with a metal. Here is magnesium, Mg right here, and it's an alkaline earth metal, so it always has a charge of +2. So its name is going to be magnesium bromide. Now notice we do not need to put Roman numerals here. Why not? Because both of these are type 1 metals, as your book calls it, which means they always have the same charge, so we don't need to say what the charge is. As chemists, we know that potassium is always +1 and magnesium is always +2. We know that this is an ionic compound because it begins with aluminum, which is a metal. And the name of this will be the name of the metal, aluminum, and then sulfide. This is a monoatomic ion based on an element from the periodic table, and so it retains its root and ends in "ide." If you've got all these right, give yourself 3 pats on the back. Now, let's look at naming compounds that it's not as easy as what we just saw. We're going to try and name ionic compounds that have what your book calls these type 2 metals, metals that have variable charges. And when we write the name, we must include the charge. So how do we know what the charge is? We're going to use the anions to help us figure that out. So let's look at our first example, TiCl4. What I do is I always write down what I know. I know it's ionic because it begins with a metal, Ti. Here's titanium on the periodic table right here. So I'm going to write titanium, and then I know that this is chloride. It is a monoatomic ion. It only has 1 capital letter, and its name is based on the root and ends in "ide." Now what I have to do next is figure out what the charge of this is. I've got to write it here as a Roman numeral. And as I said earlier, I'm going to use this to help me figure it out. Whatever the charge of my cation is, it's got to be equal and opposite to the charge due to my anions here. I have 4 chlorides. That's what my formula tells me. And I know from the periodic table that each chloride has -1. So if I have 4 of them, my total charge is -4. I have 1 titanium here, so the charge has to be +4. So this up here must be +4. Now that I know the charge, I can finish my name here. It is titanium 4. This 4 is the charge of the titanium. How did I figure it out? Based on what the anion charge is. This has to cancel out this. Okay, so now let's write down what I know. First we find Pb on the periodic table. Here it is, and its name is lead. So I write what I know, lead bromide. Now because this is what your book calls a type 2 metal, I've got to say what the charge is, because it can have several different charges, and if it has a different charge, its formula is going to be different. So we need to write down what the charge is. And we figure out what the charge of this is based on the charge of anions. The charge of anions never change. Okay, so I have 1 lead. Whoops. Whatever its charge is, it's got to cancel out the charge due to 2 bromides. When I look at the periodic table, I see that bromide is a halogen, so therefore it has a -1 charge. My formula says I have 2 bromides, so I have a total charge of -2. That means my lead must have a charge of +2. So now that I know my charge, I can finish naming my compound, lead 2 bromide, where this Roman numeral is the charge of my cation. Okay, let's write down what I know. I've seen Fe before, and I know that it stands for iron. And then I know with 1 capital letter as my anion, this is sulfide. I know iron's a metal, so this has to be an ionic compound. I also know that iron has a changeable charge. Here's iron on the periodic table, and it's not one of my non-changeable elements, so I've got to indicate its charge with Roman numeral in its name. And I'm going to do that by looking at the charges of my anion. Sulfide has a charge of -2 because it's in the oxygen family and 2 columns away from the noble gases. My formula says that I have 3 sulfides, so I have a total charge of -6. My formula also says that I have 2 iron atoms. And when I add up the charges, they've got to equal +6. Because my total charge of the cation has got to cancel out the total charge of the anion. And there's only one number that when I add it to itself will give me 6, and that is 3. So now that I know the charge, I can finally name this iron 3 sulfide, and this is the charge of my cation, indicated as a Roman numeral. So pause the slide and see if you can correctly name these 2 compounds, these ionic compounds that have metal cations with variable charges. The first thing we want to do is find these 2 on the periodic table so we can name them and see whether their charge actually does vary. Here's titanium, here's copper. They're not alkali, they're not alkaline earth, and they're not aluminum, zinc, or silver. So they do have a variable charge. Titanium and copper are going to be our base names. So I'm going to write down what I know. Titanium oxide and copper oxide. Now I have to use my math to figure out what the charge on each metal cation is. Okay, I have 1 titanium, whatever its charge is, has got to cancel out the charge of my oxides. I have two oxides. The oxygen is two columns away from noble gases, so its charge is -2. Everything in this family is a charge of -2. So its total charge is -4. Therefore, the charge of my titanium must be +4. So now that I know my charge, I can finish naming. Titanium 4 oxide. Notice there is not a 4 anywhere in this formula. This 4 is the charge of the titanium. Now let's look over here at my copper oxide. I have two copper ions according to my formula, and the sum of their charges has to equal, be opposite to, the charge of my anion. I have one oxide, so its charge is -2. My total charge here, therefore, has to be +2, and therefore each copper must have a charge of +1 to add up to +2. And I know you can barely see that +1 there, but you won't have problems seeing it there. Even though our charge is just 1, we must include it in our name for it to be correct.